Okay, so good morning, everyone. So today we're going to continue our STAAD lecture. Okay, so last time we started a problem. Okay, so let's see here. I'm going to go through it right from the beginning. Okay, so we had a beam. Okay, that looked like this. And those dimensions here, we have 5 feet, 5 feet, and 5 feet. And here this entire span is 10 feet. And here this span is 10 feet. There are loads applied on this beam. The dead load looks like this. So for the dead load and the live load looks identical, except they have different intensity. So here the dead load, this was 10 pounds per foot, or 10 kilopounds, 10 kips per foot. Here this was 20 kips per foot, and the dead load here, the intensity of the dead load was 10 kips per foot. For the live load, it looks the same but different intensity. It's just 1/2 of the dead load. So the live load here is 10 kips per foot, and the live load here is 5 kips per foot. Okay, what we want to do is input this problem, okay, and start finding the internal forces for the dead load and the live load and combinations of them. Okay, so let's try to start modeling this problem. So we're going to open the STAAD model. I'm going to start it from scratch here. And then we're going to start a new project, and plane 1, you can name this whatever you want. Okay, so you can name it anything and save it to any place. The units here in feet, the unit length, and the length is in feet, and the forces is in kilopounds. And then next, and add beams, and then finish. Now it started with this grid. So what we did last time, okay, we had a 15 feet span, and then 10 feet span, then 10 feet span. So I'm gonna make this grid, I'm gonna edit this grid here, okay, and then make it just 3 distances in the X, and just 1 grid in the Y. And for the grid in the X, maybe, you know, we can change. This is what we did last time, so maybe we can change it this time. Maybe we're gonna have the grid of 3, 4, 5, 6, 7, maybe 7 distances in the X, and each one of them is 5 feet. Okay, so you have many ways, you know, to input your geometry. So now the first beam, each of this, you know, so this is 5, 10, 15, so this is the first element, and then the second element is 10 feet, and then the third one is 10 feet as well. Okay, and then done. And then we can change the view to the XY view. So this is our beam now, okay, the 3 members, 15 feet, and then 10 feet and 10 feet. Okay, you can check the length is over here. So 15, 10, and 10, this is the length of the 3 members. And then we go here, so this is, we're done with the geometry. If we need to change anything in the geometry, you go here, okay, to change the geometry. But we're done with the geometry, so we're gonna go to the general tab here, and then we're gonna go one by one. So the properties here, we're gonna define a section. So let's say the beam section, this is, let's assume 2 sections. So let's say that the section over here, this is 40 by 20 inches, while the section here is 30 by 20 inches. And here it's 30 by 20 inches, a reinforced concrete beam, okay? So let's input those sections. So we need to define the section, a rectangular section. We're gonna need to define 2 sections. So here, as you see the units, okay, so we went here to general, and then properties, okay? And then on the right window that opened over here, we press define, okay? So as you see here, when we go to a rectangular section, we want to define a rectangular section, the units here are in feet, okay? So we want to change this to inches, so we're gonna close this and then go to the input units, to change the input units. So here on top, we're going to change the input units. Which part? So now we're going to go here, input units. Everyone can see this? We're going to change the input units. Instead of being the length being in feet, we're going to input the length in inches, okay? And then we're going to press OK, okay? And then we're going to go to define again here, okay? Press define, and then a rectangular section. Now it's in inches, okay? So y, the depth, okay? We have 2 sections. One is 40 by 20, and then we're going to add this section, and then we're going to add another one that is 30 by 20, and then we're going to press add again. Now we're going to close this window, close. As you see here now, we have 2 sections defined, one that is 40 by 20 and one that is 30 by 20. What we just need to do right now is select the 40 by 20 and assign it to the first member, okay? So I'm gonna click on it, okay? Click on the first member, on the first section here, and then assign. Use cursor to assign, and then press assign. So we're gonna assign it to the first member here, okay? And then I'm gonna select the second section, the 30 by 20, and then use cursor to assign, and then I'm gonna assign it to this member and this member, and then close, okay? So now we assign those sections to their individual members, okay? And then we're gonna go to the next tab here, okay? Specifications. Do we need to define any specifications? Do you remember last time where we used those specifications? We used them if we want to define an internal hinge, okay? We don't have an internal hinge over here, so we don't need really this specifications tab. And then we're gonna go to the supports, okay? So now for the supports, we have fixed support. If you go here, we have fixed supports at the ends, and then pinned supports at the internal supports here. They are pinned supports. So we need to define those 2 supports. So once you press the support here, it opens this window, okay? So we're gonna press create, okay? And then here we have a fixed support, okay? And then we're gonna add this. So now we have this support 2, it's a fixed support. And then we're going to create another one that is pinned. So here we're going to press pinned, okay? It knows what, you know, it's fixing all the forces or the displacements and releasing all the moments, okay? And then we're going to add this. So this is a pinned. So here we have support 2 being the fixed support and support 3 being the pinned support. Now we created the 2 supports. What we want to do now is assign those supports to where they belong, okay? So to see the nodes that we're gonna, you know, start assigning those supports to, we're gonna go here. Everyone can see this icon, symbols and labels, okay? And then we're gonna press it, and then here for the nodes, okay? I want to see the node numbers, okay? And then press apply and okay. So those are the nodes here, okay? I'm gonna select the support 2, which is the fixed support, and then use cursor to assign, and then press assign. I'm gonna assign this here and here. So those are the fixed supports. And then I'm gonna select support 3 and use cursor to assign and press, it's already pressed, okay? So I'm just gonna assign it to node 2 and node 3. And that's it, okay? We're done with assigning the supports to the nodes where they belong. And then close. We're done with the supports. We're done with the members, the geometry. Now we can go to the load definition, okay? So now for the load, I have dead load and live load, okay? So let's go here, okay? And add, okay? No, sorry, new, press new, okay? And then here load case, new load case, okay? So the first load case number 1.
Where was new?
Hmm?
Where was new? Oh,
okay, so here we press new, okay, can you see it now?
Yeah.
New, and then here on the top, press load case, okay? So we have load case number 1, and it's a dead load, okay? And you can name it whatever you want, okay? So I'm gonna name it dead, okay? So this is a dead load, and then I'm gonna add this. So I'm just defining that here that I'm having a dead load, okay? Let's start defining this dead load. We can definitely start adding the live load, but let's get finished or done with the dead load first, okay? So now we here, once you added this, you have this dead load over here, okay? A dead load case, okay? But there is nothing, there is no loads there, okay? We have to add some loads to this dead load case. What's the loads that we have to add, okay? We have to add those loads, okay? A trapezoidal load over here, a trapezoidal load, and then a triangular load and another triangular load, okay? That's what we have to add, okay? So let's start doing this. Let's start adding those loads. So here, pressing the dead load, okay? Save. Pressing the dead load, okay? And then I'm gonna press add, okay? So now, as you see, if your dead load already includes the calculation of the own weight of the beam, okay? So you should make this factor equal to 0, okay? If you leave this factor equal, if you leave it as -1, it means that it's going to calculate the own weight of the member based on the dimensions that you input and the material that you chose, which was concrete, okay? And it's going to add this to the dead load. So it depends on whether you already calculated the own weight of the beam or not. If you already calculated the own weight of the beam and added to the dead load, you should make this factor equal to 0. You don't want to duplicate or have your dead load containing the own weight twice, okay? So let's keep the factor as 0, okay? If it's already calculated, okay? Maybe in the project you can just assign the sections and leave the input, this factor as -1. Don't calculate the own weight of the beam itself, okay? Save yourself some calculations. And then we want to input here member loads. what type of loads do we have? Okay, so on the first member here, we have some uniform load right in the middle. Okay, it starts at 5 and ends at 10. Okay, so and the intensity is 10 kips per foot. So it's in the global GY, okay? Always it's GY. G means global, okay? The global Y direction, okay, of the entire problem. And Y is the Y direction, okay? So if here Y is the vertical direction. And then W1, the intensity of that load, it was negative 10. Yes?
What does the PY while local mean?
Okay. Those are the, local directions, okay? What does local direction mean? If you have a vertical member, okay? So actually the X direction is the direction along the length, the axis of the member, and Y is perpendicular to it. So, you don't want to get confused with this, so just deal with the global ones, okay? So now D1 is the distance. So as you see here, this is in inches, okay? We didn't change this, so we need, let's close this before inputting. So we didn't press add, okay? We didn't add this yet, okay? Let's change the units first. So as we did in the first time, we're gonna go here to the input units. I guess we have to delete the dead load first before changing the units. Let's add input unit change is not allowed while editing load items. Okay, so let's go back to property and then change the units to feet and press OK. Okay, and then go back to load. And then for the load cases, we're gonna add a load case again, a dead load. Just go to any other tab other than the load and definition, okay? And then here for the dead, we're gonna add this load, okay? Make this factor equal to 0, and then go to member loads. Now it's in feet, so negative 10, the distance D1, the distance from the start of the member, it's 5 feet. And then D2, the distance to the end of the load is 10 feet. And then add. As you see here, it's negative 10, not 10, okay? 10 is upwards, negative 10 is downwards. And then we press add, okay? And then now we want to add another load, okay? What's that other load? What we defined here is just the uniform load right in the middle, okay? We want to add this triangular load that starts from 0 and ends at 10, okay? So again, we're gonna go here to trapezoidal load, okay? W1 is at the start intensity, and then W2 is negative 10, the final intensity. D1 is the start of this load, it's 0. And D2 is 5, and press add. The third part of the dead load in the first member here, it starts here at 10 and ends at 15. It starts with negative 10 in kips per foot and ends at 0, okay? So it starts with negative 10 and ends with 0. And then D1, this negative 10 is at distance 10 from the start of the member, and D2 is at 15, okay? And then add, okay? Trapezoidal load, okay? And then let's go and add the loads for this member, okay? It's 20, okay? The intensity is 20. It has an increasing load and then decreasing load, okay? From 0 to 5, it's increasing, and then from 5 to 10, it's decreasing. So let's add this, and it's 20 kips. So here, this is trapezoidal as well. It's negative 20, okay? It starts with 0 and then ends at negative 20, okay? and this is starts at 0 and ends at 5. Okay, everyone did this? This is the first part of the triangular load. And then I'm going to press add. And then the second one, it's the opposite. It starts with -20, 1 second, and then 0. It starts at 5 and ends at 10. Yes?
Why would we not start at 15?
Because this is, it assigned this, the distance is measured from the start of the member. We draw different members, right? The first member was 15, and then the second member is 10 feet long, right? So it's the distance is measured from the start of the second member. Okay? And then add. And then for the third load here, it's a triangular load, and the intensity is 10, not 20. So I'm just going to add this load now. So it starts with 0 and ends with an intensity of -10 through a length of 0 to 5, and then add this. Oops. And then I had a mistake here. It was -190, but I'm going to fix this now. So, and then the other one is -10 and then 0 and starts at 5 and ends at 10 and add. And then close. Now we have those loads here. Can you see those loads? We want to assign 1, 2, 3, the first 3 to the first member, and then the second 2 here to the second member, and then the last 2 to the third member. I just need to edit this one, okay? As you see here, I'm just gonna change this to double clicking it. It showed all the details. I'm just gonna make it -10 and press change and close. Now it's -10.
That should be -190.
I input it wrongly. It was -190. It's -10. Okay. So now, as you see those loads, you see those question marks. It means they are not assigned yet. You just define the load. You need to assign them to the member where they belong to. Okay. So I'm going to select the first one here. Okay. And use cursor to assign, and then assign it to this member. And then select the second load and assign it to the first member, and then select the third load and assign it to the first member, and then select the third load here and assign it to the second member, and then this load and assign it to the second member, and then the third load, sorry, this one, and assign it here, and this one and assign it here. Okay? So now I define the loads all over each element. Okay? Any questions here? Do you want to take a few seconds to...
Yeah.
And as you see, all those loads are defined in the dead load. Okay? This is the dead load case. Okay?
Okay, how do you assign these? Select this one.
Okay, create them from the beginning. Just create them again.
Okay, anything else after that? Close.
Okay. Let's continue. Okay. So now this is the dead load. Now we want to input the live load. Okay. So before we input the live load, okay, this what I'm going to discuss right now has nothing to do with the STAAD software itself. It's a structural concept. Okay. For the live load, the dead load has to be applied over the entire beam, because the dead load is the weight of the beam itself. It's the weight of the own weight of the building. Okay, so it's always there. The live load, what's the live load? Why did we call it live load? Live load is a load that would change its location, right? We are a live load, right? We are now in this room. Maybe just 1 hour from now, this room is gonna be empty, most probably, right? So a live load is a load that can change its location. Okay. So now for those 3 spans, okay, when we want to apply our live load, we know that the live load can change, okay? Would we apply it over the entire beam? When you apply your live load, where do you want to apply it? You want to apply it where you're gonna have the maximum bending moment, right? Where you apply it at the location where it's gonna give the maximum bending moment. You might think if you apply the live load over the entire beam, that's the worst case scenario. Everywhere there is live load, right? No, this is not the worst case scenario. It's the worst case scenario if you're looking for the maximum reactions. But if you're dealing with the bending moment, if you want to find the maximum bending moment, it's not that case, okay? You need to apply, so the worst case, okay? You don't know which the worst case for, you know, the bending moment, if you want to calculate the bending moment at different sections, the worst case for the bending moment at each of those sections is different from the other case, okay? So for example, if you want this beam looks like this, if you want the maximum moment here, the maximum moment to be or the moment at this moment, at this point to be at its maximum, okay, you need to apply the live load here and here. You don't apply it here right in the middle span, okay? If you want the bending moment right in the middle here to be the maximum, you would apply the live load in the middle span, and the outside spans you don't apply your live load, okay? So a rule of thumb, okay, put the live load on 2 consecutive spans and then leave 1 empty, okay, or 1 and 1, okay? So what we did here is we have it on 1 span and we left the other span empty. So here, as you see here, you have a live load here, you didn't apply it on this span, and then you apply it here. You have this one empty, and then you apply it here, and then you didn't apply it here. And then the second case, or the second thing that we want to have for the live load is you apply the live load in 2 consecutive spans. So I'm going to put the live load here, and then no live load here, okay? This case is going to give the maximum moment at the support here. Okay? And then I'm going to leave this span empty and then put the live load on 2 consecutive spans. Okay? Those cases are going to give the maximum bending moment at different points. Okay? So how many cases do we have here? 4. Okay? We have 4 cases. This is case 1 here. Case 1, 2, 3, 4. We want to input all those cases, okay? We have this software, it's doing everything for us. We just have to input them and it's going to calculate the bending moment for each and every case, okay? So as you see, the cases is just, you know, a combination of the life load. Once you apply it on the first and third span, on the second span, on the first and second span, on the second and third span. Okay. So you can definitely input those 4 cases separately, or you can, you know, input the life load in each span and then combine them together to get those 4 cases. Okay. That's what I'm going to do right now. I'm going to define life load 1, okay? What's life load 1? It's the life load on the first span. Life load 2, it's the life load on the second span. And then life load 3, it's the life load on the third span. And then I'm going to combine them together to get those life load combinations, okay? So I'm going to go here again and press new, okay? And load case. And then this is live. I'm going to call this live 1, okay? And add, and then live 2 and add, and live 3 and add, and then close. Now we have those 3 cases here. Live 1, live 2, live 3, okay? What's live 1? Live 1 is the life load on the first span. So let's start defining this. So I'm going to come here on live 1 and then press add. What do we want to add? We have to have this factor as 0, okay, for the self-weight, and then go to member loads, and then we're going to define exactly the 3 loads that defines the trapezoidal load. The uniform load right in the middle, the first triangular load, and the second triangular load, as we did with the dead load. Just the magnitude is different. The life load is 1/2 the dead load. It's 5 kips per foot. So I'm going to define here a uniform force. It's -5. D1 is 5. D2 is 10. And then add this. And then I'm going to add here a trapezoidal load. It starts with an intensity of 0 and ends with an intensity of -5 at a distance of 0 and a distance of 5. And then add. And then the second triangular load, it starts with an intensity of -5 and ends with an intensity of 0 at distance 10 and ends at a distance of 15, the end of the member. Okay? And then add. And then close. Now we have those 3 loads. I'm just going to assign those to the first member. Okay? So use cursor to assign this one, and then assign this here, and then assign this one to the first member. So this is the life load on the first span. This is live 1. Okay? And then I'm going to start defining live 2. Live 2, and then press live 2, and then press add. Okay, so here the self weight is 0, okay, and then we go to member load, and then we want to define 2 trapezoidal loads to define the triangular load. Okay, the first one starts with an intensity of 0 and ends with an intensity of -10 at a distance of 0 and ends at a distance of 5, and then add, and then the symmetric part of the triangle, it's the opposite. It starts with an intensity of -10 and ends with an intensity of 0. The distance is 5 and then 10. And then add and close. Now we want to assign those to the second member. So select it and press assign. It's assigned here, and then this one, and assign it to the second member. Okay? So this is live 2. Now we want to define live 3. What's live 3? Live 3 is another triangular load, okay, with an intensity of 5, not 10. So let's select live 3 and then press add. The factor here is 0. And then member load. And then go to trapezoidal load. It starts with 0 and ends with -5 at distances of 0 and 5, and add. And then the other half is the opposite. It's -5 to 0 at 5 and 10 feet away from the start of the member. And then add and close. Everyone following what's going on over here? Okay? And then I'm going to select this and assign it to this member, and select this load and assign it to this member. And then close. Now we're done with the loads, okay? I'm just going to open it again, live load here. And here we have the load case details. We have dead 1, live 2, live 3. Just expand each one of them. You can see the details of what you input, okay? Now, we want to define those load cases for the live load. The live load here, okay? We have those load cases, okay? On the first and the third span, and then on the second span, and then on the first and second, on the second and third, and so on, okay? Now, let me go through more details here, okay, on what we're going to do. You know the load case combinations, right? According to the ASCE 7, the ASCE 7 load combination. You remember this? The load combinations, there are 7 load combinations, right? When you analyze your member, your structure, you have to analyze it according to those load combinations. In the ASCE 7, 1.4 times the dead load, or 1.2 times the dead load, plus 1.6 times the live load, and there is another term, but we only have here dead load and live load, okay? And then the third load combination, you have to analyze your member for the dead, 1.2 times the dead load plus the live load, and then 4, you have 1.2 times the dead load plus 1 times the wind and live load, and so on. So as you see here, we want to input those because those are the loads that might give the maximum loads. So we want first to have just the dead load multiplied by this factor 1.4, okay? And then we have 1.2 multiplied by the dead load plus 1.6 multiplied by the live load. And the live load here represent the 4 load cases that we discussed, okay? So we want to define those load combinations, okay? The live load cannot be on the beam alone. You have to add the dead load through those load combinations. So that's what we want to define now, okay? So now I'm gonna press add, okay? And then, I'm sorry, new, I'm gonna press new, okay? And then here, we have press load case, okay? And then here, we're gonna press combination, okay? I'm gonna combine some of those loads that I defined together, okay? So what I have to combine together, so let's say here, the first load case here, we have just 1.4 times the dead load, okay? This is what I want to define now, 1.4 times the dead load. So here, the available load cases, I'm just going to press the dead load and move it to my load combination. Just press here to move it to my load combination. What's the factor here? The dead load is multiplied by 1.4. Okay? And then I'm going to press add. Okay? If I close this now, you will find this C, this load combination over here. What's this? This is just 1.4 times the dead load, okay? The dead load that I defined is just multiplied by 1.4. This is the first load combination, okay? And then we're gonna press new and load case combination over here, okay? This is called load number 6. This is load number 6, and it's called combination load case 6. You can change the name here if you want. And for the project, you definitely need to change the names so that they can be descriptive of what you're doing, okay? Because you're going to have, I calculated the number of load cases that you're going to have in your project. There are 113, okay? So you need to have the, good names so that you can realize what load case you're having, okay? It's 113 is not too much. We're going to input just 5 load cases here in a minute, okay? 113, it's going to take you, what? 30 minutes, maybe half an hour, okay? So it's not something scary, okay? So now, what we want to do now is 1.2 multiplied by 1.6 times the life load. What life load? I have to input 4 load cases. Here, I'm going to start with this. The life load here and the life load here, okay? So now, just coming here, I want to have this dead load and the life load. Just pressing control, you're going to select multiple cases here. Life 1 and life 3. And then I'm going to add those to my load case, okay, or load combination. Here, the dead load is multiplied by 1.2, while the life load is multiplied by 1.6, and this is a life load as well, so it's multiplied by 1.6. And this is the load combination, another load combination. I can call this, I can change the name here. I'm going to name it D plus L1 plus L3. Okay? And then add. And then the second load here, it's the life load is only on the second span. Okay? So I'm just going to get this dead load and life 2 and combine them together. The dead load is multiplied by 1.2. The life load is multiplied by 1.6. I'm going to name this D plus L2. Okay? And then add it. And then the third load combination. We have the life load on the first 2 spans, okay? So it's L1 and L2. So just minimize this. So we are going to have the dead load plus life 1 and life 2. Those are the things that I'm going to use in my load combination. The dead load is multiplied by 1.2. The life load is multiplied by 1.6. And this is the life load in the second span, so I have to multiply it by 1.6 again. And then add. And then go back here. Now we need to have the life load on the second and the third span, okay? So here, going back to the problem, we have the dead load and the life load on the second and third span. This is what composes my load combination. The dead load is multiplied by 1.2. The life load is multiplied by 1.6. And add. And close. So as you see here, we define those load combinations. 1, 2, 3, 4, 5 load combinations. In your project, you're going to have 113 load combinations. Okay? I'm going to tell you what are those 113 load combinations. Okay? But it's just a load combination. Once you define the load, you just add them together. That's it. Okay? Now, if you read through the description of your project, okay, you're required to draw the envelope of the bending moment diagram. What's the envelope of the bending moment diagram? So let me go back here. This is a concept here. Now we had those load combinations, okay? We had those 5 load combinations, right? Where the life load is applied on different spans, okay? If the software is going to draw the bending moment for each one of them, so how many bending moment diagrams you're going to have? 5 for each of those cases, right? Bending moment for each of those load combinations that you had, okay? So let's draw those bending moment diagrams. Let's say the bending moment diagram for the first case, according to the notation that the software is using, okay? Negative is drawn up, okay? and positive is downwards. So let's say this is the first load combination. Okay? And then for the second one, okay, what's the second one? The second one was the life load on the second span. So it would look something like this. Okay? And then the life load on, or the third load combination, okay? For the third load combination, it's on the first and second span, so that maximizes the bending moment at the support, the second support over here. So it would look maybe something like this. Okay? What are those? Those are the bending moment for each case, okay? And then for the second case, or the next case, okay, it's the life load on the second and third span. That would give you a bending moment that would look something like this. Okay? It's so messy, right? Okay. Now, the concept of the envelope. The envelope is just putting all those bending moment diagrams on top of each other like this, and then just get the envelope of them. I don't care what's inside over here. I'm looking for the maximum of all of the cases all together. I don't care what's over here, okay? I don't care what's over here. I don't care what's inside. It's the envelope, okay? The outside envelope of this bending moment diagrams all together. Okay? This is called the envelope, okay? As you see here, you will see at this specific moment, for example, there are two bending moments. There is a positive one and a negative one, okay? Why is this? Because this is the envelope. It comes from many load cases, okay? It's not just one load case, okay? So how to make the software, the STAAD software, draw this envelope for you? This is what you're required to find in your project. Find the envelope, okay? For all the load cases that you're gonna model, okay? So how to do this? So we're gonna go here, we're gonna save this, and then load envelopes, and then press add. What are the load envelopes? I want to draw the load envelope for what? For those load combinations. This is this combination, and this combination, and this one, and this one, and this one. The load combinations, those 5 load combinations that we defined, okay? And then add. Here you can just say stress, okay, or none. If you leave it as none, it will ask you to change it, or it's gonna change it for you. But we can leave it as none, and then here move those here. So my envelope is for those load cases. Why didn't I add the dead load for the envelope? Because the dead load alone is not a load combination. I just defined the dead load, okay? The load case that you have to study according to the ACE 7 is 1.4 times the dead load, or 1.2 times the dead load plus 1.6 times the life load. You don't study the life load alone, okay? It doesn't exist alone. So now this is the load envelope, and then close here. So now we defined a load envelope, okay? Based on those, it's the envelope of those load cases. And we're done, okay? Now, let's see here. Let's go to analysis. Just add, press add here to add a perform analysis command here to your input file, and then press close and close. And then we go to analyze on top here.
What do we do with the analysis?
You press here, analysis and print. You just press add. You have to do this only once. If you do it more than once, it's going to give you an error. Okay. And then we're going to go here to analyze, and then run analysis. Save. Good. No errors, no warnings. Great. Yeah, I'm sure you're gonna have some warnings, some errors. Warning is not a big deal, okay? But an error is, it's not running. If you have an error, it's not gonna run, okay? For a warning, it's running, but just some warnings. And then we're gonna go to post-processing, done, and then here, for the envelope of load cases, we just want the envelope of the load combinations, so I'm just gonna move those back here. We just want the envelope of the of those load combinations, and then press apply and OK. You can go ahead now and see, you know, the deflection, the bending moment. Let's see, this is the bending moment for load combination number 6. This is the bending moment for load combination this load combination, the dead load plus L1 and L3. You can see the bending moment for each load case, okay? The shear force diagram for each load case, okay? This is, I pressed MZ over here to see the bending moment diagram, okay? And this is here the load combinations. This is for the dead load alone, okay? This is for L1 alone, okay? This is for the live 2 alone, and those for the load combinations. And then this is for the, let's see, the envelope here. As you see, for the envelope, can you see here, the envelope, you have those, you know, what we discussed. Okay. Why is this? Because it's the envelope of many load cases together, of the load cases that we defined together. Okay? You want to find the magnitude of those moments.
How do you get the moment diagram to pop up?
Just press Control and then scroll up or down. It's going to change the scale. Okay?
No, how do you get it to come up in general? Like the,
Just press MZ over here.
I don't think, mine won't let me click it, it's all grayed out.
If it's grayed out, it means it didn't, you know, that there was a warning, okay, or there was an error.
I have any warnings or?
Okay, so we're gonna go through it, you know, but you just press MZ over here. It's gonna get you the bending moment, okay? And now let's say you want the reactions. You can find the reactions for any load combinations, or here the beam. This is the bending moment diagrams. You can get to the graph, and then this is the bending moment, the values of the bending moment, okay? Let's say the envelope here. This is the magnitude for the bending moments of the envelope on the first member over here, or the second, or the third, and this is for the shear as well. Okay? As you see, the shear is a curve because the load is triangular-like. So the shear is a curve, it's not straight lines. So this agrees with what we learned. Okay? Any question? Yes? Just come here when you're on post-processing, come to beams, and then press graphs. Okay? Any question? Any question? Great. So now let's see how what we did so far is a beam. Okay? We did a beam, we did all those load combinations. Let's see how you input the geometry of the 3D frame that you have in your project. Okay? I'm going to do this with you step by step, the geometry of your 3D project. Okay? So this is the geometry that we have. This is the plan view of your project. This is 30, 36, and 30, and then 30 and 30. And there are, it's a 3-story building. The first story is 15 feet high. The second two are 12 and 12. Okay? So let's now go to a new, and then I'm going to start with a plain one. Okay? I'm going to name this structure 3, and the units are in feet and kilopounds. Okay? And then press next and finish. Now it have this grid. Okay? Horizontally, okay, I'm just going to start. We have a 3D structure. Okay? I'm going to input one frame, and then I'm going to replicate it. Okay? And then connect the frames together. Okay? So I'm going to input this frame here that is passing through girder C. Okay? Yes?
Can we talk about the exam for the week then, if you don't mind?
The exam is still, it's
Thursday, I think, next Thursday?
this third,
Next Thursday.
next, not this week's.
Not this week.
Okay,
Yeah.
so maybe next time.
Okay.
Okay? So now, we have 30, 36, and 30, okay? 30, 36, and 30, so maybe we can, the common factor is 6 over here, so we can have 5 grids, 6 grids, and 5 grids. So total of, how much? 16 grid, okay? So here, I'm gonna edit this grid, okay? I'm gonna have 16 grid, and each one is 6 feet. For the height, we have 15, 12, and 12. So the common factor is 3. So we're gonna have 5 and 4 and 4, so 8 plus 5, that's 13 grid as well in the vertical direction. So 13 grids, and each one of them is 3. And then press OK. Now this is the grid, okay? We want to start drawing our members. So the column here, it's the first one is 15, and then from 15 to 27, and then from 27 to 39, right? And then in the horizontal direction, it's 30, and then 36, so it's from 30 to 66, and then from 66 to the end, and then here, as we go down, it's 27, and then 12, 15 here. And then down here. I'm just gonna press escape, okay? And yes?
I have a quick question. Well, if we actually hit escape,
You want to add a member?
yeah.
Okay.
add member.
So we want to add a member here. So snap node beam, press snap here, snap node beam, and it will allow you to draw a member, okay? It will move back to draw a member.
Is that
Here, snap,
geometry?
no, just go to grid, okay? Here, press this, okay? And then we have a column here. I'm just gonna draw it as just one member, and then press again here, add this member here, and then I'm gonna add a member here, and then escape, and then again press a member or add a member here, and that's it. And then now I'm gonna close this, and this is the first frame, okay?
So we don't need to put one across the bottom.
No, the bottom is the ground, okay? Yes? Okay, so you come here, you press this snap node slash beam, it will allow you to draw a member, okay? Now, a very, very important point. What we have here, I have this member drawn as just one member from the start to the end. And this member, I draw it as just one member from the start to the end. The interaction between them, there is no interaction. The software here is going to just feel that there is no interaction between them, although they are connected in real life, right? This is the column and the beam. They are connected together, okay? If you leave it as an entire member like this, the entire horizontal member and the entire vertical member, the software is not feeling the connection between them. You have to break them, okay, at the intersection here. Yes?
How do you delete a node? I have an extra node that I don't need.
Just select it, okay, or see what's the node number, and here you can just delete it. Just come here and delete it in this table. So how we're going to break those elements, okay? So always do this. Select, okay, I'm going to select everything, okay? And then go here, on the top here, okay? Geometry. And then I want to intersect selected members, and then press intersect, okay? And then the tolerance here, if they are far away for certain distance, they're still gonna break it at that point that is nearer from each other, so we can have this to be 0, the tolerance. And then press OK. It says 8 new beams created. Press OK. What are those 8 new beams? Now you see this was 1 member, now it's 3 different members. The column was 1 member, now it's 3 different members. Yes? Just select them, just, you know, draw a window, select everything. Okay? Now this is the first frame, okay? Now this frame is replicated at a distance of 30 and 30 feet, right? So I just want to make a copy of this. Before making a copy, okay, of this, let's make it easier first, so that when I make the copy, I save some time, okay? Let's define the supports, okay? So in your project, we're gonna have the supports at the bottom being fixed supports, okay? So let's define the supports at the bottom here. So we're gonna go to General, and then define the supports, and create a fixed support and add it. And then now we're going to select it and assign it to this node, this node, this node, and this node. Okay? And then close. Okay? You can start adding the members as well, right? The sections. Right? You have different sections, you can start assigning the sections. So assign, let's say, the column sections. What's the column section? The column, all girders are 40 by 20, so let's define a section that is 40 by 20. So we go here to the properties, and then define a rectangular section. Now this is in feet, so let's change the units first to inches. Okay, and then define a rectangular section that is 40 inches by 20 inches, and add it. And then the columns, what about the columns? The columns are 20 by 30 inches, okay? So I'm going to add a new section that is 20 by 30, and then add, close. Now I'm going to select this 40 by 20 and assign it to the beams or the girders, okay? So assign here, here, here. And then select the column section and assign it to the columns. I'm trying, to define everything I can before I replicate this frame, so that, I don't do those calculations for each and every frame, okay? And then close.
That's a good question.
What?
Do we need to have that selected as steel? Instead of concrete? On the right
No.
hand?
What do you have in your project? Those are reinforced concrete, okay? So the material is concrete.
I typed in 40 by 20 and it's showing 480 by 240. Is that my units? What's going on there?
Just make sure that the units is in inch, not in feet. Okay? Now, we're done with this frame. We just want to replicate it. Okay? So I'm going to select this frame. I want to replicate it in what direction? So let's get a 3D view here. This is in the X, Y plane, right? You want to replicate it in the Z direction. Okay? You want to replicate it in the Z direction. For how many images or copies we want to do for this frame? How many images or copies? This is this frame. Just 2 copies more. Okay? At a distance of 30 and then another 30. Okay? So selecting everything. Yes?
I'm behind. I just assigned the specs or,
The properties, the sections. Okay, you define the supports.
yes.
Just okay, you're not behind. Just select everything. Okay? That's it. We're here now. We want to replicate this, okay? We just want to make copies of this. So how to do this? We're going to go to geometry here. Everyone on the same page now? We're just going to copy, go to geometry, okay? And then go here to translational repeat. Okay? Translational repeat. And then I want to copy this in the Z direction. So just select the Z direction. Okay? I want to replicate it in the Z direction. And then the number of steps, how many copies I want to do. I need 2 copies. Okay? This is the number of steps. And then here for step 1, the first copy. It's what's the distance between the original one and the first copy. Okay? It's 30. Okay, it's now in inches. I need to escape and change the units again to feet. Okay? Make sure you are doing the correct thing. Change the units to feet first. Okay? And then I'm going to go to geometry. And then translational repeat again. Make the direction in the Z direction. I need 2 copies. The distance here, this is 30 feet, and then from the second and the third copy, it's 30 feet as well. Here it says generation flags. What do you want to copy? The geometry or everything that you define? Everything that you define, you want to copy it. Okay? The supports, the definition of the sections, I want to copy everything. And then press OK. Now it just did those copies of the frame. Okay? Now I just need to define the girders in the other direction. Okay? In this direction. We're going to just draw them. Okay? So I'm going to go back to geometry over here. Okay? And then add beam, okay? And press, I'm just going to draw a beam member here. And then another one here. And then another one here. And then another one here. Okay? Those are the beams on the top, on the roof. Yes? 2, not 3.
Me too.
Were you selecting the entire frame? I don't think so.
I don't know where you saw it. I think I missed it. This is the way I can.
Hmm?
No, I didn't have this. Let's do that again.
Okay. Now, let's define the sections here. So this one, those ones, let's define the sections. So let's go to general. And then the section here, let's select this section. and assign it. Use cursor to assign it, and then press assign. I'm going to assign this to this member, and to this member, and then to this member, and then to this member. Okay?
How'd you add those beams earlier real quick?
Just come here, this add beam icon. Can you see the mouse? And then just draw, once you press it, you're going to be allowed to draw between the already drawn nodes. Okay? So now I'm going to unselect everything and then select those beams that I just drew on the floor, and then I want to replicate them in the y direction, right? In the first floor and the second floor. So I'm just selecting them and then go to geometry and then translation and repeat. I'm just going to select replicate them in the y direction and number of steps. So 2 steps. The first step, it's negative how much? 12. And then negative 12 as well. Okay? Moving down. And then press OK. It added those members in the first and second floor. Okay? This is the geometry. Okay? Now, we just have 3 minutes left. It's your time now, okay? I'm not going to do it. I already taught you how to do it for the single beam. You're just going to have to do this for the training. The loads that you calculated by hand, right? You did the calculations for the dead load, for the life load, for the wind load, for each and every member, right? Just define the dead load, the life load, and when you define the life loads, okay? Again, for the life load, just do as we did over here. Define the life load on those part, and then those part. And then you're going to have 4 different load combinations for the life load. Okay? For the wind, how many different wind load combinations or different wind load cases that you have? No, not 2. Why did you say 2? In the equation there is positive and negative, right? You remember that term, the external pressure plus or minus the internal pressure, right? So those are 2 load cases. But also you have, in the project I say you have to input the load blowing from the east to west and then from the west to east. So wind has to go from this direction to this direction. So in this case this is the wind board and this is the D board, okay? And then it goes from east to west. In this case this is going to be the wind board and this is going to be the D board. So those are 2 different load cases. And the plus and minus signs, so 2 times 2, you have 4 load cases. Okay? It's not 4, it's 8. Why 8? Because this is a flat roof, so to calculate the wind load on the flat roof, you have to use the ASE 7, chapter 27. Okay? And you're going to see that CP has 2 different values. So you're going to have 2 different load cases multiplied by those 4 load cases. So you have 8 different wind load cases. So for the life load, you have 4 different life loads. For the wind, you have 8 different wind load cases. Okay? The dead load, it's just 1 dead load case. For the snow, you just have 1 snow case. Okay? And then you're going to go through your load combinations. Okay? For the load combinations, let me take a few minutes more so that we can finish this now. Okay? So let's write the load combinations for you. Okay, all the load combinations here. This is the first one. Okay, it's 1.4 times the dead load. The second one is 1.2 times the dead load plus 1.6 times the life load. Why it's not writing? Yes, okay. Plus 0.5 times the live load on the roof or the snow load. The third load combination, you have the live load or 0.5 times the wind load plus 1.6 times the live load on the roof or the snow. The fourth load combination looks like this: the wind plus the live load plus 0.5 times the live load on the roof. Just you're going to find those load combinations in the ACE 7 in chapter 2, or the snow load. And then the fifth load combination, it's 1.2 times the dead load plus 1 times the earthquake load plus the live load plus 0.2 times the snow load. The sixth, you have 0.9 times the dead load plus 1 times the wind load case. 7, you have 0.9 times the dead load plus 1 times the earthquake load, seismic load. Now, for the first load combination, you just have 1.4 times the dead load. How many load combinations is within this load combination? Just one. Because the dead load is the dead load over the entire structure. That's it. Here, in the second one, the dead load is just one load combination. For the live load, as we did, you're going to have different live load cases that you have to model, okay? So here, you're going to have 4 different live load cases. Plus live load on the roof. For the live load on the roof, you have different 4 live loads on the roof, okay? And the snow, this is 1. So actually, you're going to combine those together, okay? So it's 4. You have 4 combinations here, multiplied by 5. So this one actually contains 20 load combinations. Combined together, 20 different permutations. You understand what I'm saying over here? You have 2 biases, okay? 1 to 6 and 1 to 6, okay? This one, okay, this is the first bias, this is the second bias. This one can take load case 1, 2, 3, or 4. This part can take 1 or 2 or 3 or 4 or 5. You just have those different permutations that you have to, model. Here, you have live load or 0.5 of the wind load, okay? So this is 4, and this is 8. It's this or this, so 4 or 8. So it's 4 and 8 load cases, and then this is, you have 4 and 1. So you have actually 12 times 5, so this is 60. Yes?
Is there a way to mass produce these, or do we have to do each of these individually?
You have to do it each individually. So you're gonna, that's where you're gonna have to name your cases, Okay, and so on for every one over here. Okay? Any question? I guess this concludes our STAAD model. The good news for you, I was recording what we did over here, and I'm going to post it on Blackboard. Okay? Any question? So from next lecture, it's going to be in our regular location at the library. Okay? Okay. Thank you a lot.
I've been trying to work through it. I'm just having a little bit of difficulty. I wanted to check and see if I can slightly on the right track.
Okay, let me first